we're asked to evaluate each of the three combinations. Notice how each combination is given using two different notations which are equivalent. Here we have 8 choose 6, here we have 12 choose 9, and here we have 12 choose 3. So in the most general case, when we have n choose r, this is equal to n factorial divided by r factorial times n minus r factorial. So while we are only asked to evaluate these, I do want to mention that combinations do occur in the binomial theorem as well as in combinatorics and probability. So to put some meaning behind these calculations, if we have n choose r, this will give the number of ways to select r items from n distinct items when order does not matter. Another way to think of this is n choose r gives a number of ways that you can form groups of size r from n distinct items. So for example, for 8 choose 6, this value will give us a number of ways that we can form groups of 6 people from 8 people. So to evaluate this by hand, the numerator is going to be 8 factorial. The denominator is going to be 6 factorial. And then we'll have 8 minus 6 factorial. So this would be 8 factorial divided by 6 factorial times 2 factorial. One way to make sure we set the combination up correctly is if we ignore the factorials for a moment, notice how 6 plus 2 is equal to 8. And this property should always hold true if we set up the combination correctly. Now there are a couple ways to evaluate this. If nothing else, we should expand the factorials. So let's go ahead and do that. 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1. And 2 factorial is equal to 2 times 1. This is kind of the long way. We'll take a shorter approach in the next example. But this still works. Now we'll simplify this. 6 over 6 simplifies to 1. 5 over 5, 4 over 4, 3 over 3, 2 over 2, 1 over 1. And we're not done. Notice that 8 and 2 do share a common factor of 2. There's 1, 2, and 2, and 4 2s and 8. Notice how the denominator only contains factors of 1. And the numerator is 4 times 7, which would give us 28. So again, to put some meaning behind this value, if we have 8 people and we're forming groups of 6, we can form 28 different groups. Next we have 12 choose 9. So the numerator will be 12 factorial. The denominator will have 2 factorials. The first factorial is 9 factorial. The second factorial will be 12 minus 9 factorial, which will be 3 factorial. And now to simplify this one, we're going to take a slightly different approach. Notice how we have a 9 factorial in the denominator. So when I start to expand 12 factorial, I'll have 12 times 11 times 10. But notice how the remaining factors would be 9, 8, 7, 6, 5, 4, 3, 2, 1, which is the same as 9 factorial. So I'll stop here and write this as 9 factorial. And then for the denominator, I'll leave 9 factorial and expand 3 factorial, 3 times 2 times 1. Notice in this form, it's less writing, and 9 factorial over 9 factorial simplifies to 1. And notice that 12 does contain a factor of 2 and 3, so we can simplify this further. There's 1 3 and 3 and 4 3s and 12. Now we can simplify the 2 and the 4. There's 1 2 and 2 and 2 2s and 4. Again, notice the denominator is now 1, so we're left with 2 times 11 times 10, which is equal to 220. So one way to think of this result is if we have 12 people and we're forming groups of 9, we can form 220 different groups. And now for the last example, we have 12 choose 3. The numerator will be 12 factorial. The denominator is going to be 3 factorial. And the second factorial is going to be 12 minus 3 factorial, or 9 factorial. And before we do a bunch of unnecessary work, let's compare this fraction to this fraction here. Notice how they're equivalent, and therefore the result is going to be the same. So this would be equal to 220, just as the previous example. to understand why this makes sense, if we go back to the group idea, if we have 12 people and we form a group of 9, since there's 3 people left over, that would be the same as forming a group of 3. So again, every time we form a group of 9, we're forming a group of 3, and therefore the different number of groups in both cases would be the same. Okay, hope you found this explanation helpful. Thank you for watching.